Maya Gilchrist. She is a PFAS analyst in our water assessment section of Minnesota Pollution Control. Previously, she worked as a site assessment and remediation geologist for environmental consulting. She's recently obtained her MS in Earth Sciences from our University of Minnesota and holds a BS in environmental science from Northeastern University. If you could welcome Maya with me.
Thank you for the introduction, Emily. Can everybody hear me okay?
You're sounding good, Maya.
Awesome. Well, thanks so much for having me. I'm really happy to be joining you all today and talk a little bit about the work that we've been doing here at the Minnesota Pollution Control Agency to really better understand sources of PFAS and develop some resources for communicating this information across our programs and really for any interested readers. So I will go ahead and share my window here. All right, is everybody able to see this title slide okay?
Yes.
Coming through clear.
Great. All right, so just to start off with a bit of an outline for what I'm going to be talking about today. So I'll start off with just a brief introduction to PFAS and kind of
Maya, you're going to break up. It may be a bandwidth issue. I would suggest turning off your video while presenting.
kind of the motivation behind this PFAS industry sector research project.
Sorry for the technical
and give
issues.
an overview of the framework behind this work.
So Maya,
somebody have a
we lost you for about
better.
Yeah, we lost you the last couple minutes.
Oh no, can you guys hear me?
We can hear you, but we cannot. We're seeing a black screen.
Okay. Oh, okay. Let me figure out what's going on here.
Okay. It appears maybe your internet connection isn't good.
Okay, let me just try and figure this out really quickly. Very sorry for the delay. All right, are you guys able to see my screen now?
We are, and that's about where we lost you, so this is perfect.
Okay, awesome. I apologize for that. Thanks so much for letting me know. All right, well, moving right along here. So just wanted to show you a brief outline of what I'm going to be talking about today. I'll start off with a bit of an introduction to our PFAS program work in Minnesota, and talk about kind of the goals and the motivation for doing this more specific research project into industrial sources of PFAS. I'll give an overview of the project, and then talk about the first report that I worked on as part of this project, which goes over PFAS applications in the metal plating and finishing industry. And then talk about some other relevant efforts to PFAS source identification and reduction that we have going on in Minnesota. And then hopefully have some good time for questions and discussion. So I know that this group is likely very familiar with PFAS already, but I just wanted to give a quick overview and get us aligned on the definition of PFAS, and kind of give an introduction into what I'm going to be talking about today. So PFAS refers to per and polyfluoroalkyl substances. These are a class of chemicals that are based on chains of carbon-fluorine bonds, which are one of the strongest bonds in organic chemistry, giving PFAS a lot of unique traits, such as durability, oil and water repellency, properties of surfactants, the ability to prevent combustion, but which of course also make them very difficult to treat and remove from environmental media. Minnesota's definition of PFAS is compounds containing at least one fully fluorinated carbon atom. This is a pretty broad definition. There's a few different possible definitions out there, but this leaves us with a class of diverse compounds consisting of thousands of different PFAS chemicals. So because of all of the useful traits of PFAS, these chemicals have been widely applied in industry and commercial products since about the 1950s and continuing on to today. Their uses range in a variety of different kinds of applications, from consumer products like paper and food packaging to more industrial products such as pipelinings for oil and gas. The uses of PFAS are numerous and sometimes hard to predict. Again, there are thousands of different PFAS compounds out there that really have a wide variety of different uses across industries. Some of these are better known, but some of these can be really challenging to know about and to identify. So just a little bit of background about Minnesota's work on PFAS. In February 2021, the state of Minnesota released our PFAS blueprint, which really supports a holistic and systematic approach to addressing PFAS. PFAS work has been ongoing in Minnesota since the early 2000s, and Minnesota has been a leader on PFAS work in many ways. But what this blueprint really sought to do was to provide kind of a unifying framework across all of the different programs within the Pollution Control Agency and our other state agencies working on PFAS, and really provide a strategic path forward. The blueprint identifies three key needs for addressing PFAS in the state. The first one of these is going to be to prevent PFAS pollution wherever possible. PFAS treatment and management can be very time-consuming and very costly, and we recognize that preventing PFAS is necessary wherever possible. We do also recognize that when PFAS pollution prevention has not occurred or pollution has already occurred, that there is a need to manage pollution and to mitigate risks to public health and to the environment. And of course, in instances where PFAS has been released, we need to clean it up through our various remediation programs. But the area that I'm going to be focusing on today is really this kind of number one strategy of PFAS pollution prevention. So I really like showing this image. I think that it gives a sense of kind of the scale of the PFAS issue across our environment, and really helps to ground us in all of the different environmental programs that PFAS touches. So as an artificial family of chemicals, PFAS originate in these upstream industries that produce or use PFAS. From there, they make their way to our homes via consumer products, or can be discharged directly to wastewater treatment plants or directly to groundwater from the industries in which they are used. From there, water can be conveyed to surface waters or leached into groundwater. PFAS in products ultimately end up in landfills or incinerated, and then travel along either air pathways or water pathways to ambient environmental media. So this cycle of PFAS really encompasses all of our environmental programs here at the Pollution Control Agency, from industrial permitting programs to municipal waste treatment and management programs, and on to our programs that deal with addressing contaminants in surface waters, in fish, and in drinking water. So we really identified as part of the blueprint a need to better understand these industries upstream that are producing or using PFAS, to be able to address PFAS more efficiently across our programs. So the report that I'm going to be talking about today is PFAS in the metal plating and finishing industry. This initiative was kind of born out of that need to understand PFAS usage within different industrial and commercial sectors, and to provide resources to the different programs that are working on PFAS. The resulting project is an effort to provide summaries of the different priority industry sectors, which detail PFAS use across various processes, provide information about the environmental release pathways of PFAS from these industry sectors, and provide considerations for source reduction, including an overview of possible alternatives to PFAS within these industries. And so again, these resources are intended to be useful to folks working in various programs, supporting remediation site investigations, to industrial users working on permitting requirements, to municipal users who might be engaged in source identification and reduction work, and even to our technical assistance providers who are working on the ground with businesses that may be seeking to reduce or eliminate their PFAS use in their processes. So kind of the framework for this industry sector research is firstly a basic understanding of what these industry sectors are engaged with, the different processes that are occurring within businesses, and why PFAS is being used. As part of this report, tailored to Minnesota specifically, we sought to understand what the presence of these industries were like in Minnesota, and what we can kind of expect to see as far as PFAS work within these specific facilities that we have in our state. And so the next part of this research is to identify how PFAS are released to the environment from these industries. Why are we concerned about PFAS use within these sectors? And then how can future releases be minimized? So the first set of industry sector resources focuses on PFAS uses in the metal finishing industry. So metal finishing is a general set of processes that seek to provide strength and durability to parts that are used across a wide variety of industrial and commercial sectors, including the auto industry, aerospace applications, and even furnishing and building industries. PFAS is largely used as an additive to suppress metal fumes, particularly chromium fumes, and to improve the quality of the final plate in the case of metal plating, or to improve processes like coating or degreasing that are often used in conjunction with other applications like plating. So this industry will include chrome electroplating, which tends to be the dominant source of PFAS within this sector. But there are applications for PFAS in many processes beyond chrome plating, such as plating with other metals, anodizing, etching, and cleaning, as I just touched on. This image to the right shows a metal rod being plated with chrome. This is an open bath, which is pretty typical of chrome plating processes. And PFAS can be used as a surfactant applied to the surface of these baths to lower surface tension and suppress chromium misting, and kind of results in some final products like the examples that you see here. So we chose to focus on metal finishing for the first leg of research as part of this project because it's been shown widely in other states and in some federal studies conducted by EPA that metal finishing facilities tend to be a major industrial source of PFAS to wastewater treatment plants across the country. Metal finishing in Minnesota specifically is a pretty large industry sector, representing a significant portion of GDP here, with a number of facilities dispersed across our state, both within the metro area in the Twin Cities, as well as in outer Minnesota. And so this map that you see here shows the locations of facilities that were identified based on NAICS codes. So NAICS codes, I'm sure many of you are familiar with these, but that refers to North American Industrial Classification System. This is a classification system used by the federal government to identify businesses based on broad industry classifications. And so this map represents different NAICS codes that are associated with metal finishing processes that have been identified in the literature to be associated with PFAS use. So from metal coating and engraving to electroplating and other types of fabricated metal product manufacturing. So I want to go over a little bit of the history behind chrome plating and metal finishing, and to provide some of the context for how PFAS has been used and regulated throughout this sector. So chrome plating with hexavalent chromium began as early as the 1920s, but it wasn't until the 1950s that we saw the first PFAS-based fume suppressant enter onto the market and begin to be used by the industry widely. This was around the time that PFAS-based surfactants started to be adopted generally by different industry sectors. So until the 1950s, hydrocarbon-based fume suppressants were largely used by the industry in order to suppress chromium fumes, primarily as a worker safety measure. But PFAS became adopted in the 1950s. In the 1970s, the use of plating with trivalent chromium began to be adopted by the industry. And this is important because trivalent chromium tends to not be associated with PFAS use quite as heavily. However, I'll note that trivalent chromium is not necessarily applicable to all industrial needs. It tends to be used more heavily for decorative applications. So in the 1980s, we see the beginning of PFOS-based fume suppressants specifically. So earlier generations of PFAS fume suppressants tended to be based on different kinds of PFAS. Some of these were cyclic PFAS and some older PFAS. But in the 80s, we started moving away from those and into PFOS-based fume suppressants, these tended to have the best performance overall for the chrome plating industry, and were used in the subsequent decades pretty heavily as the industry standard for mist suppression. And so in 1995, we start to see the regulation of hexavalent chromium fumes happen at a federal level. So these PFOS-based fume suppressants become very important for the industry in maintaining compliance with those air quality standards set at the federal level. In the early 2000s, PFOS started to become phased out across the United States. But there was largely an exception for the metal plating industry due to its important use in suppressing those toxic hexavalent chromium fumes. It wasn't until about 2012 that the rule was promulgated to start phasing out PFOS in fume suppressants used within the chrome plating industry, with that final compliance date set in 2015. And so I don't have this pictured on this timeline, but today, PFAS-based fume suppressants tend to be based on 6,2-FTS. So 6,2-fluorotelomere sulfonate has been pretty widely adopted as the alternative to PFOS. So as I mentioned before, PFAS applications within metal finishing broadly go far beyond chrome electroplating, which is one of the better known applications of PFAS within this industry. From the 1950s to present, PFAS have been used for all manner of processes involved in finishing metals, ranging from electroplating to plating on plastics, anodizing, etching, powder coating. The list goes on. I've provided kind of a select list as outlined in the larger report. And so PFAS, due to their functions as surfactants, are very useful for a manner of different types of products that are used within these processes. They're used largely as wetting agents and fume suppressants to suppress those hexavalent chromium fumes in the cases of chrome electroplating, but they can also be used as additives for a number of other purposes that again, tend to get added within these baths in order to ultimately improve the quality of the final metal product that is being finished. And so like I just mentioned, PFECHs tended to be used pretty widely in the past, starting in the 1950s through about the 1980s. Picking up in the 1980s, PFOS had become the industry standard in the metal finishing industry. And today, 6,4-FTS is the most commonly used PFAS and mist suppressant products. However, a number of other PFAS compounds have been used throughout history, kind of in some on less common bases. Some of these have been identified through the patent literature, others from more industrial sources. But as you can see, there's really a range of different kind of compounds that we're looking at within this industry beyond kind of these three more commonly known chemicals. I wanted to share an image of this table. This is not a complete table, but was taken from the supplementary information file to this report that is available online on our PCA website. But this provides kind of a more detailed view of all of the different PFAS compounds that we were able to identify in our literature search that have potentially been used within the metal finishing industry sector. We provide chemical information such as CAS numbers and structural formulas, as well as some background about what function the PFAS is serving within these products and any identified trade names that we were able to find from the industry sector. So you can think of this, trade name or product name column as something that you would want to look for if you were an industrial user looking to identify the possible sources of PFAS in your processes, or if you were a business assistant to one of these facilities. All right, so shifting gears a little bit, we've covered the different applications of PFAS within the metal finishing industry, but I want to talk a little bit about how PFAS is ultimately released to the environment from all of the processes identified as part of this research. So really the primary way that PFAS is conveyed from this industry tends to be through the industrial wastewater streams. If you think back to that image of the chrome plating bath that we saw earlier, those contain a level of PFAS in them when PFAS-based mist suppressants are applied, as well as any other PFAS additives that have been applied. And so those PFAS get discharged when those plating and finishing baths are changed out. Those baths tend to be changed out by industrial facilities on the order of months. A secondary source of PFAS to the environment is through air emissions. PFAS escape through these baths, which tend to be open to the air and can be emitted either as fugitive emissions through vents or emitted through stacks if there are not other engineering controls present to remove PFAS from air emissions. PFAS can also be present in solid waste or hazardous waste generated by metal finishing facilities. When the baths are changed out and the liquid is separated from residual metal sludge, PFAS, and particularly longer chain PFAS, can become entrained in that residual sludge and then be discharged to the solid waste management facility that is going to be handling those sludges. PFAS in products tends to be a pretty nominal source when we're talking about PFAS and metal plating. PFAS tends to not be incorporated into the final metal plates, but rather is used as a process additive. However, there is a possibility that in certain kinds of products, PFAS could be present in the final coat. Certain types of coatings, like powder coatings, are made of fluoropolymers. So those can be one way that that PFAS in products can get out into the environment and into landfills at the end of their lifetime. So a point that I want to make is that while discontinuing the use of PFAS is a really important tool for source reduction from the metal finishing industry, it's been demonstrated through work in other states that PFOS emissions can continue to occur long after PFAS is phased out in the products being used by facilities. This figure comes from a study conducted by the Michigan Department of Environment, Great Lakes, and Energy. They did a very in-depth study of discharges of PFAS from their chrome plating facilities through wastewater and found that despite the fact that only fluorotellumer sulfonate PFAS were used in the current products and processes at facilities, that a number of different types of PFAS compounds were showing up in the effluent wastewater. These other compounds could represent either legacy emissions or degradation products of compounds that were used historically. And I think that this is an important point to recognize. PFAS tend to be very sticky. They're very good at sorbing onto different kinds of surfaces, and so can become trapped in pipes and vents and equipment present at industrial facilities. Also taken from this report done by Michigan, industrial pretreatment tended to be very successful in fully kind of eliminating PFAS emissions. So some other source reduction strategies that we identified as part of this research. Of course, the most important and lowest hanging fruit is going to be to eliminate use of PFAS in products wherever possible. Another is going to be to phase out uses of chromium wherever possible, and particularly hexavalent chromium. PFAS is largely used in order to suppress chromium fumes. So in processes where chromium can be substituted out for a less toxic constituent, that can have upstream effects on the amount of PFAS that is needed to be used in processes. Cleaning or changing out equipment wherever possible can help reduce some of those legacy emissions of PFAS. Air scrubbers can be very good tools for reducing PFAS discharges through vents or stacks. And finally, using closed coating reactors can be helpful in suppressing fumes and eliminating the need for PFAS-based fume suppressants. And of course, we covered the option of wastewater pretreatment in the event that other control measures have been taken and PFAS emissions continue to occur. So you can find these published industry sector summaries on MPCA's website under our PFAS Studies and Report webpage. The report on PFAS and metal finishing is up there, along with the second report that we've completed on PFAS in the textile and leather industries, which was another priority sector that we were interested in better understanding within Minnesota. And so we plan to develop additional sector resources based on just different program priorities and informational needs that come up. We really learn more about sources of PFAS every day. And so, continually doing this work of identifying the sources and identifying ways that we can start tackling these sources is going to continue to be important for as long as we maintain our PFAS program work in the state. I did want to touch on some other relevant PFAS source identification and reduction efforts that we have going on within Minnesota. Another kind of complementary project to the one that I just presented is an initiative that we completed this year on PFAS source evaluation and reduction. This project was born out of a legislative appropriation that directed our agency to reduce sources of PFAS to municipal waste treatment and management facilities. There were kind of three key goals associated with this project: to identify those upstream industrial sources of PFAS, evaluate the different ways that we could start tackling source reduction at those industries, and then to develop tools to provide to municipal users to be able to implement some of these source reduction strategies. And we worked very closely with a stakeholder group consisting of waste treatment and management professionals, as well as other municipal representatives who provided a lot of really good feedback in shaping this project. And so ultimately, the goal of this project was to provide resources for folks. And so we developed a couple of different tools to aid both municipal and industrial users in working on source reduction. So the first one of these is a tool that's meant to provide information about different industrial sources of PFAS and to identify the potential for PFAS risk in a business's processes. It provides some guidance on how to identify PFAS use within a business's operations, including some tips on conducting an SDS review and some background information about regulatory changes that industrial users could find helpful as they begin this work. Another one of these tools that was developed out of this project is kind of a searchable PFAS chemicals guide. This contains information about different PFAS compounds that are associated with different types of industry that you can search for based on either NAICS code or chemical information or your chemical names. And this is really meant to be kind of an interactive and living tool that will update as new information becomes available, and meant to just kind of be a handy search tool for folks to have, in their belts. If you see a specific chemical come up and want to quickly get an overview of what kind of industry you may be looking at as a source of that chemical, this provides kind of a starting point for folks that are embarking on source reduction work. One other effort that's been going on within the state is actually being conducted by the Minnesota Technical Assistant Program at the University of Minnesota. So MNTAP has been doing some great work on PFAS source reduction via a grant provided by EPA. This is a 3-year grant and has been kind of divided into a 3-phase project with the goal of preventing PFAS pollution and ultimately limiting human exposures to PFAS. So MNTAP has been focusing on 3 main industry sectors as part of their project. One of those is the metal manufacturing and fabrication industry, which I covered. And they're also looking at the food and beverage manufacturing industries and the chemical manufacturing industry. And so one of their key goals, which is very complementary to some of the work that we've been doing on a state level, is to create resources that can be provided to both municipal and industrial users. They are starting to develop a very nifty PFAS source mapping tool to provide to wastewater treatment plants that provides information about different potential sources of PFAS within a geographic area. And they're also developing some industry-specific assessment guides that can be used by folks to determine where to start looking within their operations to identify PFAS and again, provide some source reduction strategies. So these 3 projects are just 3 efforts that we have going on in the state. And really what they have in common is they're all meant to provide resources to folks that are working on PFAS source identification and reduction. The universe of PFAS is very broad, and we've been working collaboratively with others in MNTAP and elsewhere to share information that can help make these resources as thorough and as useful as possible. And I do just want to share the contact information for our MNTAP staff that are working on the PFAS source reduction project. I'll go ahead and share this slideshow with Mark after our call in case anyone is interested in learning more about this project and getting these links. And that's all that I have for today. I'm very happy to take any questions now.
So Maya, Nancy posted a question. Just to confirm my understanding, the metal fabrication NESHAP prohibited the PFAS foam suppressant, but it is in several other additives and still escapes the bath through air, land, and water.
Oh, thanks for that question, Nancy. So actually the NESHAP regulation specifically allowed for PFOS to continue to be used for chrome plating mist suppression purposes. So even after PFOS was starting to be phased out in most other industry sectors, this was one where there was kind of a longer timeline given for phasing that out.
Okay, thank you. Catherine with New Hampshire asked, will you provide a link to the PFAS database tool you showed?
Yeah, absolutely. So that PFAS database tool, we're actually just working on finalizing that right now, but we're planning on having that up on our website by the end of the month. So once we do have that up and available, I would be happy to share the link with you all.
And if you don't mind sharing your presentation, if you're able to do that.
Oh yeah, absolutely. I'll go ahead and send you this slideshow.
So if anyone wants to unmute themselves and ask a question, go ahead. While we wait on that, Maya, with respect to PFAS emissions, is it, can you identify, is there one particular pathway, I guess, to the air? Would that be vaporization? Or would it come off as an aerosol? Or is it combined with a particulate solid?
Thanks, Mark. That's a really great question. My understanding is that both of those pathways are possible, depending on the PFAS compound in question. So there are some PFAS that are more volatile and can, aerosolize off of the surface of baths and be emitted to air that way. But some of them can sorb onto particles um, and be emitted through a more physical route, if that's helpful.
Okay, thank you. And I did appreciate that you mentioned 6,2-FTSA, fluorotelmer sulfonic acid. It was the replacement for PFOS. And you also mentioned in your document that this will degrade to perfluorohexanoic acid, which I believe is more toxic. So is there any move to prohibit the use of 6,2-FTSA?
Yeah, that's a really great question. I'm not aware. I guess I'm not sure if you're referring to, kind of on a federal level or at a state level.
Well, it could be either or. I know, Minnesota took a strong stance with trichloroethylene. So it could be at a state level. Yeah, Minnesota has definitely taken the lead in other situations.
Sure. Yeah, so I mean, I think that you bring up a really great point about kind of degradation products. And to me, this really speaks to the need to think of and to regulate PFAS as a class. There are just so many different chemicals out there with complex degradation pathways. Um, that I think really speaks to the need to look at these pretty holistically. And so, with regards to kind of phasing out specific PFAS, Minnesota actually just passed a pretty comprehensive ban on PFAS in products. The first wave of that law is going to start going into effect in 2025. With kind of 11 initial product categories in which PFAS will be banned for sale in the state. And then by 2032, that ban is going to extend to all uses of PFAS that are not considered to be currently unavoidable uses. And so our definition of PFAS within the state is pretty broad. It covers all chemicals that contain at least one fully fluorinated carbon. So this will extend to the fluorotelmer sulfonates and kind of all of the different categories of PFAS. As far as kind of on an industrial and commercial level, I am aware of at least one or two mist suppressant products that at least claim to be PFAS free. Not just PFOS free. I don't have a ton of information on those products, but I do believe that that's an area of active research and development. And it might be worth looking into some of those products more to see how they've progressed beyond beyond using 6,2-FTS.
Yeah, yes, you mentioned that in your article. Adotech being the one. And I don't think there's more than, say, like 3 manufacturers of wetting agents. So anyone with questions? Otherwise, I'm hogging her time. So I'm not trying to monopolize Maya's attention. Oh wait, oh no, never mind. I thought I saw something in the chat. Um, I Maya, I was surprised about chromate conversion coatings, um, as well as alkaline cleaning prep, surface prep, containing PFAS. I didn't realize that that served a role in what I presume to be a chemical reaction.
Yeah, some of these processes were very surprising to me as well when I was starting to conduct this research. I guess something that I will say, just as a qualifier on some of this information, is that, this report covers ways that PFAS have been used by some in the past or have been, known to potentially be used through patents. And I think, kind of provides a reference point for, questions to ask of facilities and places to start looking. I can't say for sure that all alkaline based cleaning processes would contain PFAS. But we know that at least in the past, that was a potential use of PFAS, and I think something to further investigate.
Yeah, that's an excellent point. At least it gives you a starting point to be able to ask the questions, and then you would hope that the entity that has a chromate conversion bath communicates with their supplier to know the ingredients. The challenge I know with some of the chemicals is when they're proprietary, sometimes there's a reluctance to actually share the identity of that particular molecule.
Right, that's a great point. And I think that fits well into Tony's question in the chat, which is, do you routinely see them on the SDS, or could they be hiding in TDSs or a direct request of the supplier? And I think that you make a really great point. Sometimes PFAS can be present on the SDS, but many times they are, the chemical identities are hidden as confidential business information or trade secrets. And, in those cases, more digging and conversation with suppliers, I think, is necessary to get some of this information. But I think that that's one of the key challenge in PFAS source identification.
And you mentioned also in your document that Teflon is used in nickel electrolysis plating. See, I thought people stopped using Teflon back before the turn of the century, but apparently it's still being used.
Yeah, that's my understanding. The resources that I was able to find and kind of the advent of PTFE based nickel plating dated back to a handful of years ago. Again, it's hard to be 100% certain how actively used some of these products are at facilities today, but yeah, that was some of the information that I had found.
So I don't know if I guess the problem is the PFAS world is very large, and identifying the toxicity of just a small part of that large family is very difficult. But there was the move towards shorter chain PFAS. I guess, do you see metal finishers pursuing the use of shorter chain PFAS in the material or in the processes that you described in your research paper?
Yeah, that's a really great question. Um, I think that overall, what I've seen, from my information gathering for this project is more of a shift towards the fluorotelomers. So going from PFOS and 8 carbon chain PFAS as kind of the industry standard into 6,2 FTS. I did find a few instances of products that were based on PFBS, which is a 4 carbon chain sulfonate compound that has been pretty largely used as a replacement chemical for PFOS. But that didn't seem to really be the dominant replacement, at least for this specific industry. I'll be interested to see what kind of happens in the future, if there will be a trend towards using short chain PFAS within this industry, or rather a move to seek non PFAS alternatives, which is what I think I would like to see.
Nancy Larson has a question. Is it correct that the Minnesota-based 3M was a major user of PFAS and is actively remediating? Can you speak to that?
Yeah, sure thing. So you are correct that 3M has been a major, not only user of PFAS, but manufacturer of PFAS. They are actively, we as a state are actively engaged in remediation activities surrounding pollution associated with 3M's PFAS manufacturing activities. This work is being conducted within the East Metro unit at MPCA, and I'd actually be happy to pop a link into the chat or follow up with an email to some information about that effort.
Okay, thank you. And Catherine with New Hampshire asked, Maya, does Minnesota have any air regulations that have mandated controls or source reduction?
Thanks. That's a great question. So as far as for PFAS specifically, we do not currently have air regulations with regards to PFAS. We do have one air emissions reporting program for PFAS that is ongoing right now on a voluntary basis, actually as part of the PFAS monitoring plan. So many industrial facilities will be, or we anticipate to be, voluntarily reporting air emissions for PFAS as part of their 2024 emissions inventory reporting. But as far as mandated controls or source reduction, we do not currently have that in the state.
So that voluntary reporting will actually take place in 2025?
No, so they'll be reporting in spring of 2024, and that will be for their 2023 inventory.
Oh, okay. Thank you. Do you target any industry sectors or everyone you think that possibly might be using or has PFAS?
Yeah, that's a great question. So we actually identified industry sectors based on NAICS codes and tried to
Oh, okay.
find NAICS codes that have been associated with PFAS use. So kind of targeting those industries where we suspected that PFAS could be used.
Now, if I recollect, EPA is coming up with a, I think they call it a questionnaire, but it's more for the pre-treatment operations. And they're going to be, I think, finalizing that supposedly next year, I think. Do you know if this voluntary reporting will kind of go along with that questionnaire? I think it's only going out to a select number of businesses identified as being users of PFAS?
Yeah, that's a really great question. I'm actually not sure. I mean, those are two separate efforts, but I think that it will be really helpful for us, to learn the information that EPA is able to gather as a result of that survey. And I think that we can do a lot of work kind of comparing, the data and emissions reporting that we get as part of our monitoring plan programs, coupled with the information that EPA is able to get. I'm not sure, I haven't heard the latest on EPA's timeline for implementing that survey, but I have my eyes out for it, as I'm very curious to see what they find. I know that there are a handful of Minnesota facilities that were included in that survey list.
Nancy asked, was there a 3M SEP, I think it stands for a Supplemental Environmental Project, that could help small businesses reduce PFAS in their operations?
That is a really great question. I actually don't know the answer to that, but I'd be happy to connect you with some folks in our East Metro unit who are working more closely with 3M and PFAS, who might be able to provide some more information.
Yeah, this is Nancy. I'll just supplement that with a comment. It's just a good reminder for all of us working with the small business communities and a lot of metal fabricators and finishers is that if there is a big industry that has a remediation or a compliance and enforcement project, we might talk with our regulators about a Sept that then could ultimately be used to help some of our smaller metal fab folks actually reduce or eliminate their PFAS sources. So just an idea for some funding that could be piped from larger industry instead of just paying a fine, possibly doing one of those supplemental environmental projects.
Thanks for that thought, Nancy. I absolutely agree that, ways to be able to get more resources for helping small businesses take on some of this source reduction work is really important. So I appreciate that.
Okay. We are at 3:00 right now. So if there are no other questions, and I definitely could go on, but I won't. Then I'd like to remind, we'll either have Tony Pendola and Lena Divakar, I hope I'm pronouncing that correctly, with Kansas State, talk about EcoNotify, climate, and the economic justice screening tool. If they're not able to do that, then I think Donovan will step up and talk about solar panel recycling, and that will be October 17th. Maya and Emily, I appreciate you both, your willingness to hear me out, prepare, and give your presentation today. I was even taking copious notes. I kind of read through your research paper. I kind of highlighted it, marked it up like heck, had lots and lots of questions, had to do lots and lots of searches, and it kept spreading and spreading. So I could have probably spent the better part of a year just trying to go down rabbit holes, so to speak. But I do appreciate the presentation. And who knows, I might even go, oh, it looks like, wow, we got 3 new messages. Okay. Oh, yeah. Oh, they're just congratulating you or thanking you for the great presentation. Actually, one of them is Leanne, my co-chair colleague. Leanne, do you have anything you want to say?
No, all good here, Mark. Thanks.
Okay. Well, I guess with that being said, I wish you a great afternoon, and I'll see you on October 17th.
Thanks so much, Mark and all. It was great to join you all today. And please don't hesitate to reach out to me by email if you have any more questions. I'm happy to chat.
Thank you very much, Maya.
All
Have a
right,
good
take
day.
care.
You too.